A particle starting from rest moves in a straight line and its acceleration is given by a is equal to 50 minus 36 t square meter per second square, where t is in seconds. Determine the velocity of the particle when it has travelled 52 meters. So there is a particle and this particle starting from rest moves in a straight line. So here particle moves in a straight line and its acceleration is given by expression for acceleration. So here acceleration is a function of time. So acceleration is equal to given 50 minus 36 t square. 50 minus 36 t square. Given equation of acceleration, a is equal to 50 minus 36 t square. So here a is in meter per second square. So here unit of acceleration is meter per second square. So here particle is starting from rest. As particle is starting from rest, as particle starting from rest means t is equal to initial time, t is equal to 0. So here time period t is equal to 0. So initial starting from rest means initial time is 0. So as particle is starting from rest, what is initial velocity? Initial velocity. So initial velocity v0 is equal to, so v0 means that t is equal to time, at t is equal to 0. So at t is equal to 0, v0 is equal to 0, initial velocity is equal to 0. Okay na? So here body is at rest, particle is at rest. So initial velocity v0 is equal to 0. And what about initial position? Initial position. So as particle starting from rest, initial position x0, let us say x. Here x represents position. x0 is also equal to 0, or we can take s0. s0 is equal to 0. v0 is also equal to 0. So initial velocity is 0 and initial position is also 0. So at t is equal to 0, v0 is equal to 0 and s0 is equal to 0. Okay. So next, determine the velocity of the particle when it has travelled 52 meters. So our ultimate goal or objective is to find velocity of particle when object is travelled 52 meters. How much distance? 52 meters. So here we need velocity of particle when particle travelled 52 meters from the rest. Okay. So okay, fine. This is all about given data. At last we need velocity. So here we have expression for acceleration in terms of time t. Remember here t is independent variable. Okay, now it does not depending upon any other variable because we measure time with stopwatch. So first of all we have to find expression for velocity and expression for position. So how do we get equation for velocity of particle and position of particle? So we can find from acceleration. See, we know that acceleration is equal to rate of change of instantaneous acceleration is equal to rate of change of velocity with respect to time, and also velocity is equal to rate of change of displacement with respect to time. So instantaneous acceleration is equal to dv by dt and instantaneous velocity is equal to ds by dt. And at the same time, so one more important concept, suppose derivative of x is dx by dt. With respect to t is dx by dt. So this is derivative. And what about antiderivative? Antiderivative means reverse process of derivative is called antiderivative. Antiderivative is also known as integration. Okay, the integral. So process of finding antiderivative of function is called integration. So derivative opposite and antiderivative or integration. So derivative opposite process, antiderivative or integration. So derivative of x is dx by dt. Antiderivative of dx by dt is x. So what is the use of concept here? See, here acceleration is equal to what? dv by dt is equal to 50 minus 36 t square. Here we need equation for velocity. So we have to eliminate this derivative. So we know that derivative of reverse process is antiderivative or integration. Apply integration on both sides with respect to t. So apply integration both sides with respect to t. So integral dv by dt with respect to t. So integral 50 minus 36 t square with respect to t. So dt. We know that derivative and integral get cancelled. So reverse process of derivative is integration. They get cancelled. We get v, velocity. V is equal to integral 50 minus 36 t square into dt. Now distribute this integral. V is equal to integral 50 dt minus integral 36 t square dt. Okay. So to eliminate derivative of v, we simply applied integration on both sides, and this is my last step. So here 50 is constant, so take out constant out of the integration. So v is equal to, okay, no? Take out 50 out of the integration, 50 integral 1 dt minus, here 36 is also a constant, take out 36 out of the integral. So 36 integral t square dt. We know that integral 1 dt is equal to t. So 50t minus 36. So integral of t square. So integral of t square is equal to what? T cube by 3. So whenever we apply integration, we always add some constant. So let us say C1. This constant is called constant of integration or integrating constant. Whenever we apply integration, we always add some constant. Okay, that constant is called integrating constant or constant of integration. So anyhow, how do you get t cube by 3 here? So remember, integral of t power n dt is equal to formula t power n plus 1 by n plus 1 plus some constant. Suppose here we need integral of t square dt. Here n is equal to how much? 2. So t power 2 plus 1 by 2 plus 1, t cube by 3. Anyhow, we already added some constants. Okay. Now next we have to find value of C1, integrating constant. To find C1, to find value of C1, apply boundary conditions. We already have two boundary conditions. So here the particle starting from rest. So what at t is equal to 0, initial velocity is equal to 0, and initial position is also equal to 0. X is equal to 0 or s is equal to 0. We consider s. Here see, at t is equal to 0. What is the value of velocity? V is also equal to 0. I think we consider V0. V0 is equal to 0. If T0 is equal to 0, V0 is equal to 0. Here T0, V0 means the particle starting from rest. Okay, just an indication. So see, put V is equal to 0. And what about T? At T is equal to 0, V is also equal to 0. So 50 into 0 minus 3 ones are 3 12s are So minus 12 into 0 cube plus c1. So what is the value of integrating constant? 0, 0, c1 is equal to 0. Okay. Now what is the equation for velocity? V is equal to 50t minus 12t cube. c1 is already 0. So this is expression or equation for velocity. So V is equal to 50t minus 12t cube. Next let us find equation of position. Okay. So we have equation of velocity. Next we need equation of position. We know that instantaneous velocity is equal to rate of change of displacement with respect to time. So ds by dt. We need s. We know that v is equal to what? 50t minus 12t cube. 50t minus 12t cube. Now, in order to eliminate derivative, we have to apply integration. Okay? Now apply integration on both sides because derivative and integral get cancelled. ds by dt, apply integration on both sides with respect to t. Integral of 50t minus 12t cube into dt with respect to t. We are doing integration with respect to dt get cancelled, derivative and integral get cancelled. So now s is equals to integral of, here 50 is constant, integral of t is what? T power n plus 1 by n plus 1. We need integral of t. So n is equal to 1. So t power 1 plus 1 by 1 plus 1. T square by 2 minus 12 is constant. Integral of t cube. T power 4 by 4. Directly I am doing. So whenever we apply integration, we always add some constant. Let us say C2. Okay, now we already considered C1 here. Let us consider C2 now. So 4 1s are 4 3s are 2 1s are 2 25s are. So S is equal to 25 t square minus 3t power 4 plus C2. So here C2 is called integrating constant or constant of integration. To find C2, to find value of C2, apply second boundary condition. Apply boundary conditions. Here what is the next boundary condition? Same. Whenever a particle starting from rest, initial velocity is equal to 0 and initial position also equal to 0. So at t is equal to 0, what is the position of the particle? S is equal to 0. Position of the particle is equal to 0. So t is equal to 0 means particle starting from the rest. So S is equal to 0. So put S is equal to 0. 0 is equal to 25 into t is also 0. 0 square minus 3 into 0 power 4 plus C2. So what is the value of C2? C2 is equal to 0. So value of C2 is 0. Put C2 is equal to 0 in this equation. You will get the equation of position. S is equal to 25 t square minus 3 t power 4. This is the equation of position. Okay. Using equation of velocity and equation of position, we can find velocity of the particle when particle traveled by a distance 52 meters. So finally we derived equations of velocity and displacement in terms of t. Here velocity and displacement are expressed in terms of independent variable t. Okay. So here we have to find the velocity of particle, the velocity of the particle when it has traveled 52 meters. When it has traveled 52 meters. Okay. So first of all we should know at what time the distance travelled by the particle is 52 meters. At what time or the time at which the distance travelled by the particle is 52 meters. Using the time period we can find velocity of the particle. Okay. So first we have to find a common independent variable t. So using this condition, see here suppose particle is travelled 52 meters. Put s is equal to 52 meters in this equation. So 52 is equal to 25 t square minus 3t power 4. So here we are going to find time at which the distance travelled by the particle is 52 meters. Now transpose 3t power 4 minus 3t power 4 becomes plus 3t power 4. Now positive 25t square becomes negative 25t square plus 52. So all terms are transposed. So obviously 0. Now 3t power 4 can be written as 3t square whole square minus 25t square plus 52 is equal to 0. Now let us assume let t square is equal to some x. Now it becomes 3 t square is equal to x, 3x square minus 25x plus 52 is equal to 0. Now this is quadratic equation because highest power of the variable is 2. Okay, we know that a quadratic equation has maximum 2 solutions. It has at most 2 solutions. So 3x square. So we have to find the solution of this quadratic equation. So 3x square minus 25x plus 52 is equal to 0. So we have two methods, factorization or using Sridharacharya formula, quadratic formula. I just go with factorization, it's very simple. So we have to find two numbers whose sum is equal to minus 25, nothing but coefficient of x, and product must be equal to, coefficient of x square and constant. 3 into 52. 3 into 52 how much? 156. Find two numbers whose sum is equal to minus 25 and product is equal to 156. So possible case is 12 and 13. Minus 12 and minus 13. N1 is equal to minus 12, N2 is equal to minus 13. Why? Why minus 12 minus 13? See, minus 12 minus 13 minus 25. Minus 12 into minus 13 plus 156. Now split middle term using minus 12 and minus 13. 3x square minus 12x minus 13x plus 52 is equal to 0. So what is the, just observe first two terms and last two terms. In first two terms, what is the common thing? 3x is common, so remaining x, 3 4s are 12, so x minus 4. In last two terms, we know that 13 4s are 52, so take minus 13 common. So here x and here minus 4 is equal to 0. Again x minus 4 common, and here 3x and here minus 13 is equal to 0. This product is equal to 0 either when either x minus 4 is equal to 0 or 3x minus 13 is equal to 0. So your product 0 avalante either x minus 4 equal to 0 avali or 3x minus 13. From this equation x is equal to 4, or from this equation 3x is equals to transpose minus 13 plus 13, x is equal to multiplication becomes division 13 by 3. So we have got two solutions, x is equal to 4, x is equal to 13 by 3. So these two are solutions of this quadratic equation. But what is the actual expression for x? What is x? Here x is equal to t square. Replace x by t square. Then t square is equal to 4, or here also replace x by t square. T square is equal to 13 by 3. So we have got two solutions for the given equation. So here what is the equation? 52 is equal to 25 t square minus 3t power 4. So we have got two solutions. The first solution, let us say t1. T1 is equal to 2 seconds. T2 is equal to 2.0816 seconds. It means the distance travelled by a particle when T1 is equal to 2 seconds and T2 is equal to 2.0816 seconds is 52 meters. Okay, no? At T1 is equal to 2 seconds, distance travelled by the particle is 52 meters. At T2 is equal to 2.0816 seconds, the distance travelled by the particle is 52 meters. Okay, no? So there are two possible solutions. So similarly, we will get two solutions for the velocity. We get two answers for the velocity. See, so now we need velocity. So ultimately we have to find velocity of the particle when it has traveled a distance 52 meters. So at t1 is equal to 2 seconds, we get v1. At t2 is equal to 2.0816, we get one more solution, v2. Okay, na? We will get two answers for this question. See, so at t1 is equal to 2 seconds, so what is the velocity of the particle? When t2 is equal to 2.0816 seconds, what is the velocity of the particle? So we have velocity equation. v1 is equal to what? I mean 50t minus 12t cube. So here we consider t1. So it is obviously 50t1 minus 12t1 whole cube. Now v1 is equal to, what is t1? t1 is equal to 2 seconds minus 12 into 2 cube. Now v1 is equal to 50 into 200 minus 12 into 2 cube is 8. So v1 is equal to 100 minus 12 into 8. 12 into 8, 96. So v1 is equal to 100 minus 96 and 4. So 4 meter per second. 4 meter per second. This is one solution. So one more solution is v2 is equal to what? 50 t2 minus 12 t2 cube. So what is t2? t2 is equal to 2.0816 minus 12 into 2.0816 whole cube. So if you calculate, you will get around minus, so negative value you will get minus 4.1563 meter per second. Remember, here negative sign represents, so negative, this is positive velocity, this is negative velocity. Here negative sign represents the particle is moving in the direction of, your particle is moving in the direction of negative x-axis. Negative x-axis. So your negative sign tells us the particle is moving in the direction of negative x-axis. Okay. So these two are solutions to the given problem.